EdExcel P3, chapter review 6, going through some differentiation questions. Question number 8 gives the following function. So we've got a function with Ian. It's got a 0.5x minus x squared. It says that x has to be a real number, any real number. Find f dash of x. So obviously, first thing just to know, f dash of x is dy dx, first derivative. And let's take a look at each of these separately. So usually when we take e to the power of x, the first derivative of e to the power of x is going to just be e to the power of x. So if we had just e to the power of x, it's always going to be e to the power of x. So nothing changes. But our e to the power of x has a function inside a function. So just apply the chain rule. So then in this case, we would have to times it by the first derivative of whatever's inside. So if, for example, we had e to the power of ax, the first derivative of ax is just a. So dy dx would be e to the power of ax, the whole thing, times by a. Okay, so if we apply that to our e to the power of 0.5x, we will get e to the power of 0.5x times by 0.5. Then we just have a nice, easy x squared. So negative 2x squared, you times the negative by the 2, we get negative 2x. So that's 3 easy marks for number A. Then for number B, it wants you to, it has this word evaluate. So you're basically just letting x equal 6 and letting x equal 7. So first we do that. If we, for example, if we had f dash of 6, we let x equal 6, so it'll be like something like this. Oopsie. Times by 0.5 minus 2 times 6. So that would be our first, put that in the calculator, and then we have f of 7. Okay. So put that in the calculator. So obviously exact same thing with a 7. I like to keep these things in brackets so I don't make any silly mistakes. So for me, I got for f of 6, negative 1.957. And then I got a positive 2.557. Okay. Now, what this shows us, they said, when they said evaluate, so they want to show that the curve with the equation of what we've done, so our curve, has a stationary point at x equals p. So we have to prove it has a stationary point. Okay. So I'm not drawing this curve, but if I just draw a percent curve, so say we had something like this, the stationary point would be the turning point, or we could have something like this. The stationary point here is at the bottom. Or you could have a point of inflection stationary point, but I'm not sure if that's this one, but where it kind of does something like this. The one thing, this one is a little bit more complicated, but the one thing all of these have in common is that the gradient of the first derivative at each of these points is 0. So for f dash of x equals to 0 at the turn at these points. But that's not the only thing they have in common. The other thing that they have in common is that the gradient changes. So this one is a sort of to the left, it's a negative gradient, negative gradient, negative gradient, positive, positive, positive. So the gradient changes from negative to positive, and here from positive to negative. And here from this one is positive, this one is negative. Okay, so the proof uses this information. What becomes important is that you have some sort of point P, which is in the middle of 6 and 7. So they say that P is between 6 and 7, and there's a stationary point there, and we need to prove that. And the way that we've proved it already is that one of these gradients at those points was positive and one of them was negative, but you have to write it out in a specific way. So the full proof, you have to say, there is a change of sign. There is a change of sign between x equals 6 and x equals 7. They also want you to state that f dash of x is continuous. So there's no breaks in it. Assume this, and then therefore. Just seeing if I missed anything. By evaluating if the curve has a stationary point, at x equals p. Okay, so there will be a stationary point in somewhere in the middle. Somewhere in the middle, there'll be a stationary point. So there's between 6 and 7. So last thing they want you to write is f dash of x equals to is 0. That just means stationary points. That's just another way of writing it. At p, somewhere in the middle. Okay. Is that enough? I'm just looking at the mark scheme. They really want you to write the whole thing. Okay, I would use therefore sign. Depends on the marker, how sticky they could be with this. So you say, therefore, our f of x has stationary point at x equal p, where p is between 6 and 7. That should be enough. That was question 8.